my next speaker, Harald Wüst from Visometry.
Visometry, yes.
And your product is called VisionLib.
Yeah.
And you're going to talk about augmented reality for the industrial metaverse, tracking manufactured items via CAD models. Wow.
Yeah.
So Harald, the floor is yours.
Yeah, thank you for the opportunity speaking here. Yeah, my name is Harald Wüst. I'm the CEO and one of the founders of Visometry. We are a tech software company, a tech startup, and a Fraunhofer spin-off. And our focus is augmented reality, especially for industrial applications. For industrial applications, and there the biggest technical challenge is to track and detect 3D objects based on their CAD data. And this is like what we provide with our first product, VisionLib, which is like a software SDK, which is a cross-platform system for iOS and Android mobile devices, but also Windows standalone platforms. So we invested a lot of computer vision, invested a lot of effort in developing computer vision algorithms for object detection. We tried with feature-based methods to match point clouds. But for industrial applications, shape-based tracking and matching methods were a way better choice. And so this was the idea of our first product, the VisionLib SDK, which is an object tracking framework where we can directly work on CAD data of physical parts, like CAD data of industrial items for any kind of machines or special vehicles, and you use these 3D CAD data to align those in camera images. And with this technology, we created this SDK, mostly addressing augmented reality applications. We have lots of customers in the area of automotive, but also automotive suppliers. And we also provide this SDK to lots of augmented reality platform providers, but also small agencies who create standalone applications for a very wide variety of application areas. So this was our first product, but since there we only have a deep tech solution and lots of stuff in the value creation chain happened somewhere else, we decided to go vertical and create a second product based on this technology. And we saw lots of value in the area of quality inspection. And therefore, we created the software product called Twin, in relation to digital twin. And this is a powerful software platform for augmented reality-based quality control. It's like a digital by design system to help manufacturing companies to deliver their quality promises much faster and with much better efficiency. So the purpose of this application is that the quality engineer can load its 3D data of its parts and then do checks if the next manufacturing steps really fit, if these parts are matching to the current production stage. Here's an example for the quality inspection use case. The quality engineer takes its iPad, loads the 3D data into the software, and then he's able to check around this welding structure. For example, if all bolts or holes are correctly drilled, or if there are any differences between the virtual 3D CAD model and the physical built object. We know there are lots of other measurement solutions. We always tell our customers that this is not a precise measuring device, but more like a visual inspection tool. So we get an accuracy of about a sub-millimeter, and we are in between a very simple manual inspection and a high precise nanometer measuring device. The advantage is that the solution we provide is very, very simple to use, and of course much less expensive than these very high, costly measurement devices. Here we have an example of one of our customers. This is a part of a big construction machine, And because our solution is like a mobile system, we can just take this out on the shop floor and detect like really huge welding structures if like all parts are consistently manufactured as the CAD data specify them. Here is an example of the incoming goods inspection. Like here, these parts are checked before they go further into the production process if all parts are correctly assembled. The idea is to test very early in the process if there are any failures to prevent like high follow-up costs when there's something mounted which is like not correct. So the biggest advantage of this system, it's like very easy to use. It's a quick setup. We do not have to do any pre-processing, no time-consuming learning phase. So it's very easy to set up, and therefore the inspections can be carried out like with much more a higher frequency. The mobile effect of this software is a great advantage because it can be carried out anywhere in the production process, and we just use like standard consumer hardware like iPads, which are like also like a low-cost hardware solution for these inspection processes. Then the basic version is mostly a solution for like visual quality inspection, but we also want to use our computer vision expertise into to go towards like a fully automated inspection of certain parts. Here we have an example of this window lifter in the car door, and with our software we can both track the different parts in relation to each other. So here we know that the window lifter, when it is mounted correctly, we can detect that the transformation between part 1 and part 2 is like in between a certain tolerance range, and then it is possible to automatically check the correct alignment and positioning of certain parts within the whole product. Here is like a similar example where a part is mounted on a table, and this can also be used to check the correct alignment of this part into the system, so that the user does not only have to decide visually if this part is correct, but it can also be detected automatically. And this is like our goal, to put like as much computer vision expertise into our system towards like a fully automated quality inspection tool. Yeah, thank you very much. If you're interested to check out our technology, you're welcome to visit us at our booth. Thank you.
From Visometry. I could allow a question. Is there any question? Harald, I think you covered it all. Congratulations.
Mm-hmm. Thank you.
So thank you all, your 4 great startups. So Alex, Oliver, sorry, it's the last day. Alex, Oliver, Tobias, and Harald, thank you for presenting your products. And I now ask the jury members to cast your vote for the startup of the day, 3. So that's all. Thank you.